Hello, this is Mr. Collier, and today we're going to be finding a line of best fit. First, let me just change this to a line of best fit because there's multiple ways to do this and multiple possible lines. But our line, to be pretty accurate, is going to have to go through the mean point, which we'll see in a second. So these are biology scores for 10 students and chemistry scores for 10 students. And I've calculated the mean for the biology scores and the mean for the chemistry scores, and we're going to plot those points and the mean point, and we're going to make a line of best fit through the mean point. Okay, so we have biology and chemistry. I'm going to put biology down here on this axis. Biology scores, and then chemistry scores over here. Chemistry. Okay, and I'm going to start by plotting the mean point, which is 54.1, 54.4, 54.1, which is somewhere about here. Actually, let me put that in green, just like it says up there. And then I'll plot all the other points in blue. Okay, so I'm done plotting the points, and as you can see, there is a linear positive correlation here. That means that students with high biology scores in general, they have high chemistry scores, and students with low biology scores, they have low chemistry scores. So there's a linear relationship here, and we can draw a line of best fit, and we're going to draw it through the mean so that we'll make it as accurate as we possibly can. So let's try and do that now. I'm going to try and draw a line through the mean, and it's probably a good idea to go through the mean and make as many points above the line and as many points below the line as possible. Let me see. Okay, so we're going to try this here. And alright, that looks about right, and it goes through the mean point. So I'm going to draw that line right here. And maybe I'll stick some arrows on it here. Alright, so there's our line of best fit. So now I'm going to use 2 points on the line to find the equation of the line. I'm going to use the mean point because I know that's on the line. And then another point, maybe not this one because it's so close to the mean point, but this one right here. It doesn't actually have to be one of our data values. It could be another point like this point here as well. We could use that to find our equation of the line. But I got these 2 points, and I'm going to find the equation of the line using those two. Okay, so our point in green here, the mean value, the mean point is, well, we have the exact value right there. It is 54.4 and 54.1. Oops. Okay, and then our other point right here, well, that's the point that's at about 38 for the chemistry score. So let me go up to our table here. 38 for the chemistry score, or 39 for the chemistry score would be the last point here, actually. So 38, 39 is this point right here. And I'm going to use that one to find the equation of our line. Alright, so we have 38, 39 as our other point on the line. So first thing we need to do is find a slope. So slope is y2 minus y1 out of x2 minus x1, which equals, in this case, 54.1 minus 39 out of the x values here, which are this. And if I calculate that on the calculator, and I could do this with alpha y equals, and I could actually a fraction, and it'll look exactly the same. So let me see, 54.1 minus 39 out of 54.4 minus 38 equals, okay, that's 0.92. So slope is about 0.92. And now we have our equation of a line is going to be y equals 0.92 x plus b, the y-intercept, which we don't know yet. So then we're going to substitute in a point to calculate the y-intercept. I'll take this one and substitute it in here. So we're going to get y, or y is actually 39, so 39 equals 0.92 times 38 plus b. And so actually we're going to have to do 39 minus 0.92 times 38 equals b. Alright, so let's do 39. Now I've got this number on my calculator, I might as well use that. Minus answer. Okay, that'll give me the exact value here, 0.9207 and so forth. So 39 minus 0.92 times 38 will give me my y-intercept. And that is about 4. So in this case, b equals 4. b approximately equals 4. So the equation of our line is y equals 0.92x plus 4. Or if you want to, you could say the y is the vertical axis, so we have chemistry. Chemistry score equals 0.92 times the biology score. That's a B, not a 13. Biology score plus 4. So this is a way of calculating the chemistry score, or an estimate of the chemistry score if the biology score is known. Alright, so let's check out another example. Here we have a graph. Below is a graph of relationship between the temperature outside and the profit of an ice cream shot. So we have a mean point and we have a bunch of points, so we can draw a line of best fit. So I'm going to try and draw a line of best fit now through the mean point, and I'm going to go for right here. Let me see. So that looks about right. Okay, it was through the mean point. There's a few points above the line. There's a few points below the line. It looks like it fits the data fairly well. So we're going to, now it doesn't ask you to find the equation of the line right now. So maybe we'll try to answer these questions without getting the equation, and then we'll answer the next set of questions by finding the equation. So how much profit do you expect the ice cream shop to make on a 21 degrees Celsius day? So if we look back at the graph, 21 degrees Celsius is here. So one thing we could do is we could look at the graph and go up to here, and it looks like it's about $500. So we can expect on a 21 degrees Celsius day to make about $500 by looking at the graph, right? So that's about $500. How much money would you expect to make on a 30 degrees Celsius day? Now here's the problem. We don't have a data value at 30 degrees Celsius. Okay, so it's going to be up here somewhere. We don't know what it is because it's outside of our range of data. So this is called extrapolation. Okay, extrapolation is outside of our data values. Interpolation is within our data values. Okay, so this is actually fairly accurate to find data values within our range of data. So this is fairly accurate. The extrapolation is less accurate because it can be a little bit predictable outside of our range of data values. So this is less accurate, but we can try it nonetheless, and it works often in a lot of cases. Okay, so we could try extending our graph or something like that, but we could also go ahead and find the equation of the line right now. So let's do that. Let's find the equation of the line. So our mean point here looks like about 18, and that's about 370 maybe. So I'm going to say that's about, not quite 18, that's 17.8. I'm going to say 17.8 and 370 is our mean point. And now if we had the actual data values, we can get a more accurate answer for the mean point, but that's a ballpark figure for now. And another point on our line, we could choose this point maybe, even though it's not our data value. That's 24,600, right? 24,600. So I'm going to use those two and find an equation of the line. So slope equals 600. I'm going to go this way. 600 minus 370 over 24 minus 17.8. So if I do that, I'm going to go alpha, y equals, get my fraction, 600 minus 370 over 24 minus 17.8. Okay, and then press equals here, and I get 37. I'm going to round it to 37.1. So that's about 37.1. So then we have y equals 37.1 x plus the y-intercept. I'm going to substitute in a point. I'll take this one. Either one would do. So 600 equals 37.1 times the x value is 24 plus b. So 600 equals, well actually let's subtract that now and solve for b. So 600 minus 37.1 times 24 equals b. And we'll do that on the calculator. 600 minus, now we have that number right there on the calculator, so I can go second function answer, there we go, times 24, and that equals negative 290. Okay, so that's about negative 290. Alright, so the equation of our line of best fit is y equals 37.1 x minus 290. And we're talking about the context of the problem. This is, what was that, profit? Yeah, it's profit, okay. So that's profit equals 37.1 times the temperature, so I'm going to do capital T, minus 290. Okay, and what this tells us is, well, we have a slope of 37.1, right? So that means you can, a good estimate of the amount of profit you make for every degree the temperature goes up is 37.1. So each time the temperature goes up 1 degree, you can expect to make about $37 more profit. Okay, and the next, let's answer this other question right now. I forgot about that. So in this question, we want to see how much profit you make in a 30 degrees Celsius day. So we can use our equation, which was 37.1 T minus 290. So P equals 37.1 times T minus 290. So we can plug in 30 degrees Celsius into the equation. Alright, and work that out, and that'll be our estimate for the amount of profit on a 30 degrees Celsius day. So let's do that. 37.1 times 30 minus 290 equals 823. So you expect to make about $823. The shop made $500 in one day. Estimate the temperature outside. Well, that looks actually just like part A, so actually that's going to be about 21 degrees Celsius.